So we've got a starry smoothhound here. Now this is a species of northeast Atlantic demersal elasmobranch. Lives and feeds along the bottom, feeding on a variety of different organisms. But starry smoothhounds particularly prefer crustaceans, things like shore crabs, edible crabs, that they can find buried in and around the sand. So these shark species are caught in a hake fishery based just down in Penzance in Cornwall. Now this hake fishery is a trawl fishery, so it trawls along the bottom, catching various species like hake, but unfortunately also these sharks as bycatch. Smoothhounds could potentially ingest various pieces, small bits of plastic, possibly from their food. So it's been shown in other studies that crustaceans have the ability to assimilate plastics within their tissues, and that can potentially be passed from the crustacean directly to the starry smoothhound. So the sharks that we research are most commonly caught in northeast Atlantic fisheries as bycatch. Now bycatch is a real problem for various species that live in the marine realm, particularly sharks. Now it's really important that we understand that bycatch is an issue for these sharks. However, whilst it is sad to see, it's great to see that fishermen around Cornwall and the rest of the country are donating some of these individuals to be used for research purposes. So when we're dissecting these individuals, we would make an incision underneath here towards the belly, about 2 to 3 centimetres deep, to make sure that we don't damage any of the internal organs, because that's what we're going to be using when we're digesting and checking for microplastics. So after we've made the incision, we've removed the stomach and the gastrointestinal tract, and we take 10 millilitres from the stomach and 10 millilitres from the GI tract, and that's what we're going to be using to digest and look inside for the presence of microplastics. So after collecting 10 millilitres from the stomach and the intestines of the shark, we treat it with 20% potassium hydroxide solution and oven heat it at 60 degrees Celsius for 48 hours. And this aids in breaking down the biological material to ensure that we only have the microplastics left. After that, we filter the solution through this fancy filtration kit here onto 50 micrometre filter paper. And that will filter through the biological material and mean that only the microplastics and microfibres are left. And we transfer that into a petri dish, and that can be analysed under microscopes. So after we transfer the filter papers across into the petri dishes, we analyse them under microscopes. Now the most commonly identified plastics that we're finding within the shark species are microfibres. Now we're also finding microfibres that are mostly blue and black in colour, and that's very consistent with environmental samples and in other species as well. So after identifying the various fragments and fibres under the microscope, we take these up to the Streatham campus in Exeter and analyse them under something called FTIR. Now FTIR bounces lasers down at the pieces of plastic and tells us their chemical composition, so we can tell what polymers they are and actively trace them back to various everyday items that we use. So we're finding fragments of plastics in our shark species. Now these fragments are coming from everyday items such as plastic bottles. So when a plastic bottle is lost in the ocean, it breaks down slowly over time due to UV radiation, wind and wave action, and these fragments slowly break down into even smaller pieces, all the way down to tiny microscopic pieces. We're also finding fibres. Now fibres are most commonly found in bits of clothing and from plastic bags. Now in clothing, fibres have been synthetically changed, and when you wash various items in your washing machine, they're passed through that system out into wastewater treatment plants and then consequently out into the ocean and into our shark species. We were also finding fibres such as polypropylene and nylon, and again based on their structure and colour, we could tell that they were probably coming from things like fishing nets and fishing equipment. The consequences that some of these plastic items might be having on the shark species in our study can be seen in other species, for example other species of fish. Now, plastics have been shown to have carcinogenic chemical compounds within them, and it can have impacts on their endocrine system, their reproductive system and their immune system as well. Although not one of the major threats to sharks globally, it's still important to understand the variety of different threats that these species face so we can implement various mitigation strategies to help save them.